Okay, so it turns on. What do we get from our calibration? Uncaled. There we go. So that's now the cal position. This is kaput. There's something in there. I'm just not using this scope properly. Look at that. Okay. Yeah, it's working. Well, I mean, channel A is working. Channel B seems to be working as well. But this isn't. It did have a little bit of bumpage on yeah. Well, in any event, it produces a trace. The trace is stable. The pots feel really nice. Like there's very little grindy feeling in them. So yeah, I think that's a win for an auction score of, well, I always have this benchmark in my head about Dave and his $50 oscilloscopes, but this one actually cost me $60. But it came with 2 other oscilloscopes, so I should probably not be complaining. Yeah. Anyways, this will be a fun resto for sure. So those knobs cannot be the originals. So yeah, we've established that there's enough working about the scope that we should probably take a look inside and see what's going on. And yeah, let's dive in. Well, let's discharge the tube and so we don't kill ourselves, and take out some boards. Back together. The interconnect goes on last. That's the interconnect between these 3 boards. There's screws here, here, and here. There is a pair of jumpers that need to be removed from here in order to be able to move this board back, and then I think we're clear, but we'll have to check. No, that pair has to come off as well. These are interconnects between those 2 boards. Well, one major mess up is the external trigger input, as well as the external trigger input for both external trigger inputs are connected by a resistor to there, and so we're going to need to resolder that back together on the other one. So sad. Now, there are a few more wires connecting this board in. There's gray, red and black, or sorry, red, brown, and white, and black and white stripes, and then there's red and white down there. And then another set on top with it going to the board on the other side of the CRT. So we've got a purple, white, and then blue, black, orange, white. And with a little wiggling, that gets you this sub-assembly out of there. To get the vertical preamp board out, we need to disconnect the delay line, as well as the 4 jumpers there, which are green, black, black, I'm going to say blue, and going from back to front. And the delay line is black, yellow, blue. Yes, that is yellow. So this thing clearly got dropped off the bench because this the fine adjust on the volts per division was bent, totally bent, and not only was the volts per division bent, the fine adjust, but so was the center shaft on here. So a little bit of judicious twisting of the metal has made this much more uniform. It's still a bit off kilter, but I think it will be okay, especially once I straighten that out a bit, and then the fine adjust will be able to rotate smoothly again. But this just needs to be straightened out a little bit as well, because it's got still a bit of some yawing in it. Now, oh crap, lost the spacer. Okay, found the spacer. So it looks like in here that's supposed to be continuous across there so that it can actuate that, and I will confirm that on the other side. But that just means that a simple bit of focus. A little bit of design work in the 3D printer will give us a replacement part for this. It's pretty simple. It's a cylinder with a hollow and a bar through it, sort of like a foot. This thing is, I'll just probably notch a slot into there so that it mates with that, and then yeah, easy peasy. Or maybe just glue another horizontal piece of bar material across there. Take a couple of notches out of there, put a piece of plastic in, some glue, and we should be all good. So there you go. Spins nice and freely. So I just need the yoke piece to fit into that potentiometer, and we'll be back in action. Cool. Those two screws and that one mounts to that, and those two mount to there and there, I believe, that allow you to get the storage control board out. And then that gives you access to those two bushings in there, and then that allows you to pull the front panel off for cleaning. So that LED up there is the reset LED. The black and gray is the time for division, and then the orange is the line LED, and that's power, obviously. And that gets us our front panel. So not too bad. I only butchered one resistor on the external sink, so yeah, I'm going to call that a success as far as a disassembly is concerned. Okay, so that piece of plastic should do just fine for turning that. Slips in nicely. To replace that, or do I make a new notch? I don't think it matters. So a bit of CY, thiocyanate in there, and then I'll trim it back and we should be good. There we go. And that should fix that. Okay, so the only thing that needs replacing is that resistor that I actually broke myself. So, Sadie, seriously, that is not helpful at this point right here. But thanks for trying. So it's much cleaner than it was. I still have to figure out what to do about these, the channel A and channel B volts per division knobs, fine adjusts. I might turn something on the lathe to replace those, because looking on eBay I couldn't find anything. This one is still a little tight. This one actually works pretty good, but you need more grippy fingers than I have. But yeah, it actually doesn't look too bad. Oh, I also have to glue the HP badge back on there because that's important. We can't not have the HP badge on that thing. Okay, contact. My line LED's not coming on. So something's not right. I messed something up. What did I forget to plug in? Or what did I plug in wrong? Oh. The jumpers that go between the three main boards. Yeah, big goof. Contact. Ah, that's more like it. Has it warmed up? Yeah, I lost the beam. And those aren't supposed to be on all the time either. Oh, what did I forget to turn? Plug back in. What? Now. I just didn't have my beam intensity up. There we go. Main, position, position. Beam intensity. Focus. All right, let's put a probe on that and see what we get. Get some sort of signal just from the noise. And what am I looking at here? X, A, B, reset, main, .1 volts, that's a half a volt per division, and yeah, probe's not called worth a crap, but I mean compensated worth a crap, but we've got something. Channel A. Channel, oh, yeah, it was DC coupled. DC coupled. That's so bizarre. Why is channel B so there's something going on with attenuation on channel B, because I can, well, I had been able to. I wonder if there was a probe in there and it just broke something, and now there's some resistance in here, so that's acting as an attenuator for your signal, or there's some capacitance in there. I don't know. Anyways, it warrants more investigation. Channel A displays, so that's half a volt for division. It's 1 volt, and I think it's approximately 1 millisecond, if I remember correctly. 1 kilohertz. Yeah. So that's on channel A, and that agrees with the 2225. Now, when I go to channel B, here's what I see. On half a volt, so there's severe attenuation going on the order of 10x. So somehow 10x attenuation is getting injected into there, and that's on the DC setting. Ground seems to be working fine. So let's position that to 0. DC, yeah, so I'm getting about 10x attenuation. And AC, I'm getting this weird signal. I'm not sure you can see that, but it's really bizarre. So what's happening? What does it look like is happening anyways? So 0.5, that's roughly 0.05 volts per division. So there's some severe attenuation happening on DC. So that's one thing that's wrong with channel B. And then the other thing that's wrong with channel B is it is doing this. Now, I have to think a bit about, or read up on how the scope is supposed to be working, and then go from there. But those are my data points thus far. Channel A seems to work, so I would suspect, I mean, the sweep is working, and it's something in the input and attenuation circuit of channel B that is not currently working. And then I also have to figure out why I've got uncal and reset lights that are continually lit right now, which they shouldn't be. In any event, that's where I'm sitting so far right now. Okay, so I thought it was weird that the AC coupling wasn't firing. So what it looks like is that this finger here doesn't go back by itself. So it must be broken in there. So it's supposed to spring back. It's not springing back. Those two, the upper two spring back, but that one doesn't spring back. So that finger's broken. So I'm wondering if there are some other fingers here that aren't performing as they should either. But chances are it's related to that finger being including other things into the circuit that aren't supposed to be included in the circuit and whatnot. Now, the question, of course, is how did that finger get broken? Because when it's mounted onto the board, everything is pretty well protected from bumblery, so I can't imagine how that would have got broken. But I think the next step is to maybe pull this guy right apart and try and do some remediation on it. Now, in order to do that, we can either do some desoldering or we can undo this screw if we can get at this screw. This screw right here. Can get at that screw there. That means we can pull that off, and then that'll give us enough room to get. Well, I can take the pot off the back. So I think I'm going to do that. Okay. So that little guy came out of here. Now, notice that these have some springiness to them, but they also might be able to be pulled out. Maybe gently, or maybe not. Well, in any event, I don't know if you can see right in there, but there looks to be a tiny bit of copper. That would be the other end of these. And on this side, you can also see a tiny bit of copper. But my guess is that this one got broken off at some point, because it does not, in terms of length, and I don't really have a good quality inspection microscope. Does that look like a fracture? I think it does. And sure enough, that's the other piece of the puzzle right there. So that little guy explains why attenuation wasn't working. Or sorry, the AC versus DC wasn't working. That pin broke. So now the question is, what do we do about that? Okay, so as near as I can figure from the schematic, there is this table. I think that is a B. It stands to reason, anyways, because AC coupling had noise on it, and that was probably because of the crappy connection. Grounding would be just, see, now let me get the order that these come in is A, B, C is my presumption. So if we're looking at DC voltages, we should have just A and B depressed. And does that follow from the working version that we've got? Let's take a look. Okay. It's a little hard to see. Let's see if I can gently move that out of the way. There we go. Okay, so A, B, and C all depressed is 50 ohm. DC is leave the middle one unengaged. So that's A, and wait, okay. Middle one unengaged. Middle one's the only one that's in, wait, okay, let's try this again. From the top. AC, middle one's engaged. Ground, ground is the middle one is open and the outside too, so that would be A and C. So does that mean that there's an errata in the manual? So we need a material that's about half a thou thick. That is 7 thou, 0.7 thou. This is looking promising right here. Ooh. 0.6. 0.48 thou. This is a little thinner, but that might just work. I wonder if I can fashion something out of that. Wow, that's ugly. Well, a crude facsimile of the Tonto's exploding headband. A crude facsimile, no, not of Tonto's exploding headband, a crude facsimile of the fingers was created out of sheet metal, and it seems to be doing what it needs to do. At least it goes up and down now, and sits below the level when it needs to, sits above when it needs to, sits below. So yeah, let's pop that in and see what problems it solves. If it doesn't create more problems. Okay, we're upside down, but whatever. Let's see what we get. Now that we're back together, we've got a trace. We've got a trace on B. Do we have a signal? Look at that. AC coupled. 0.2 volts per division. Yeah. There we go. Let's go over to channel A, make sure it's the same. Yep. Let's maybe put both of those on at the same time. Wow. So, yeah. That's something right there. That's what that is. Okay. Chomp. Yeah. Beautiful. Half a volt per division. Separate the traces. That's more like it. Okay, now we just have to do probe comp. Yeah. So that's what it was. So, okay. An explanation of what the hell was going on. Okay, let's DC on channel B. Yeah. And then, ground, and then DC on channel B, AC, DC, well, everything's shifted up. And then 50 ohm. So what was happening was there was an intermittent connection with the 50 ohm input, so that was attenuating the signal, or just throwing that whole channel B attenuation preamplifier off. It was noisy, and that's where the noise was coming from, and so it was just a mechanical problem with making an intermittent connection on one of the set of resistors and switching in different parts of the preamp, either the attenuation or the amplification for channel B. And so cobbling up a little replacement for that thing there and slipping that in is what fixed channel B. So yeah, now we have a 100 megahertz storage analog storage oscilloscope, which is kind of nice to have, actually. And maybe we'll do a little playing with the scope just to see what the various features are. But actually, I think I'm gonna take a little break because, wow, that was something else, that whole little journey there. I do want to know why I've still got this on Cal. So yeah, that is nice to have. That was a good score. It took me too long to try and to bring it up to speed, but yeah. Anyways, I'm glad that had a happy ending, and thanks for watching. See you later.
And there were those whom the radiation corrupted,
inducing physical and mental disease.